Alright, so for lesson 4, we're solving exponential equations when the variable is in the exponent. So we've been graphing them, now we're actually going to solve for the variable, okay? So just to redefine what an exponential equation is, an exponential equation are equations where the variable occurs in the exponent, and I just found another typo, an equation where the variable occurs in the exponent. So that means we have something like 3 to the x. So those things that we've been graphing, but we haven't been solving them yet. Okay? So we have a couple properties, or just one. If b, that's your base, is a positive number other than 1, which was one of our rules, right? Yes. Then b to the x equals b to the y, so my bases are the same. And they're equal if and only if x equals y. And doesn't that make sense? If my bases are the same and my exponents are the same, they're equal to each other. Okay? So here's an example of what that looks like. If 3 to the x equals 3 to the 5th, then x has to equal 5. Right. Okay? It should be obvious. Okay? No. So how do we solve these things? Because the problems are not going to be this simple. Okay? Step 1 is we need to rewrite each side of the equation so that we get the same base. So our problems are not all going to have the same base to start out with. Okay? After we have the same bases, so our bases are the same, we can then drop the bases, or what I said is set the exponents equal to each other. So we can drop the exponents or drop the bases or set the exponents equal to each other. It's the same thing. And then we can solve for x. Okay? So those are going to be the steps that we follow, and it's not going to be too bad. Okay? So let's look at example 1. For example 1, I have 3 to the x equals 1 over 81. Now, what do you think my base is going to be here? It's going to be 3. Can we get 81 into a base 3? Yeah, 81 splits up to 9 and 9, right? Which is 3 and 3 and 3 and 3. So this is the same as 1 over 3 to the 4th, right? But now, are my bases exactly the same yet? No, because this is a fraction. How can I make this a base of 3, not a fraction? Exactly. We can bring it up, which means the exponent becomes negative. So this is the same as 3x, or 3 to the x, equals 3 to the negative 4. My bases are the same, so I can drop those bases. So I get x equals negative 4. Okay? Yeah. So try example 2 by yourselves. 2 to the x equals 1 over 16. This one. 16 is the same as 2 to the 4th. So if I want to move it up, I have to make it negative. So this is the same as 2 to the x equals 2 to the negative 4. So we can drop the bases. So x equals negative 4. That's just a coincidence. And it actually, in a lot of... Okay? So example 3. What happens for problems like this? Now we actually are going to have some solving to do. So I have 2 to the negative x plus 3 equals 8. How can we get this to be a base of 2?
Oh, I did it differently.
8 is 4 times 2, and 4 is 2 and 2. So this is the same as 2 to the negative 8 plus 3 equals 2 to the... Yeah, x plus 3, sorry. X to the third power, right? No. 2 to the negative x plus 3 equals 2 to the third power. There we go. Thank you. So now I can drop the bases because they're the same. So we have negative x plus 3 equals 3. And now what can I do? Distribute. So negative x minus 3 equals 3. Add 3 to both sides. I ran out of room.
Crap.
So negative x equals positive 6.
Divide by the negative.
Divide by the negative 1. So positive x equals negative 6.
Will it always be negative?
No.
Darn, I need to.
Okay. Not too bad, right?
It's always confusing.
Okay, so number 4. Okay, what do you think my base is going to be? 2, right? This is a 2. Just a 2 by itself is 2 to the first. Okay, and this is a 4. How can we make 4 base 2? 2 squared, right? Okay, so what do you think is going to happen? This is 4 to the second power. And what am I going to do with this? Put it in parentheses, so we're going to multiply them. Oh, 2 to the second. Thank you. 2 to the second to the 2 times x plus 2 equals 2 to the first. So now my bases are the same, right? Okay, so I can drop those bases and keep it 2 times x plus 2 equals 1. Distribute. 2x plus 4 equals 1. Subtract 4 from both sides. So 2x equals negative 3. Divide both sides by 2. X equals negative 3 over 2. So we can also get a fraction as our answer.
So you said like this packet is gonna go like.
So example 5. What do you think my base is going to be here? 7. And we're going to end up doing the same thing. 49 is the same as 7 to the second. So this is 7 to the 2x equals 7 to the 2 times 3x minus 2.
Will it get harder than this?
Okay, so we can drop the bases here. So this is 2x equals 2 times 3x minus 2. Okay, so we have 2x equals 6x minus 4. I am going to subtract 6x from both sides. And that gives me negative 4x equals negative 4. Divide both sides by negative 4. So x equals positive 1. Okay? Example 6. The base is good. The base is going to be 3. So for this one, we have to change all of them. So 9 is the same as 3 and 3, right? So the left-hand side is 3 to the second times 2x equals 27 is 3 to the third. So this is 3 to the third times x minus 1. So my bases are the same, right?
Yep.
So I can drop those, and 2 times 2x gives me 4x. I'm going to start doing the distributing in one step. Is that okay?
Yes.
Okay, so 4x equals 3x minus 3.
Yeah.
Okay, subtract 3x from both sides. 4x minus 3x gives me 1x equals negative 3. Feel good? All right, number 7. What do you think my base is going to be here? 3 again. 81 splits up to 9 and 9, right? Which is 3 and 3. So 81 is the same as 3 to the 4th. So this is 3 to the 4 times x minus 3 equals. Okay, this is 3 to the first power, but I want to get it up to the top. So what's going to happen? It's going to be negative. So this is 3 to the negative 1 times 5x minus 6. It will be. Yeah. Right, so now we can drop the bases, right? So this is, I'm distributing in the same step now, 4x minus 12 equals negative 5x plus 6. Let's move the negative 5x. So let's add 5x to both sides. So that's going to give me 9x minus 12 equals 6. Add 12. 9x equals 18. Divide by 9. So I get x equals positive 2 for that one. Example 8. We have 3 to the x equals square root of 27. So my base is going to be 3, and I already know that 27 is 3 to the third. So this is the same as square root of 3 to the third, right? Oops. I said it correctly, but I didn't write it correctly. Okay. I still have a square root in front of this 3 to the third, so technically my bases aren't exactly the same yet. How can I rewrite this so that I only have an exponent? Do you guys remember? We can rewrite the exponent as a fraction. So the 3 becomes the numerator. The index becomes the denominator. What's the index of a square root? 2. So do you all agree that this is the same as 3 to the 3 over 2? Right?
Yeah.
This is from unit 6. Okay? Yeah, one of those. Okay? So we have the same base now. So now I can just drop those bases and x equals 3 over 2. Okay? So square root, we can rewrite it as a fraction. Question really, really quick. What if it was just square root of 3? What would that be?
What?
If it was just square root of 3, that would be 3 to the 1 over 2. That does come up in your homework, okay? So just be aware of that. Okay? So example 9. What is my base going to be here? 5. So this is 25 is the same as 5 squared, right? So this is 5x equals 5 times 5 squared over, what's the index here? 2. So this reduces to 1. So I have 5 times 5 to the first power. So what does that become? 5 squared. So this is 5 to the x equals 5 squared. I drop the bases, so x equals 2. Because I had this 5 on the outside being multiplied by it. So this was 5 to the second over 2, right? And that reduced to 1, so I had 5 times 5, which is still 5 squared. Okay? All right. Okay. Okay, 1 over 8 to the x equals 1 over 4 to the x plus 1. What do you think my base will be? It's going to be 2. This is the same, 8 is the same as 2 to the third, and 4 is the same as 2 to the second. But they're both in the denominator, so that means we have to move them up. So we have to make them both negative. So this is 2 to the negative 3x equals 2 to the negative 2 times x plus 1. My bases are the same, so I can drop them. So I have negative 3x equals negative 2x minus 2. Let's add 2x to both sides. So that's going to give me negative x equals negative 2. So positive x equals 2. And that was it.